Hello, everyone. Welcome to ABI Research's webinar, Small Cell and Wi-Fi. I'm Christine Gallen, Analyst Relations Director for ABI Research. Today, ABI Research's Research Director, Nick Marshall, will outline the drivers behind the integration of Wi-Fi with licensed small cells and examine the advantages and disadvantages of combined 3G LTE Wi-Fi small cell systems. We'll also cover mobile traffic growth, small cell types, carrier Wi-Fi, and standards activities. We'll conclude with an opinion on whether Wi-Fi competes with or complements small cells. My usual reminders: you can type in questions into the question panel at any time during the session, and Nick will answer them at the end as time allows. A playback of the presentation will be available on our website within a few days, and information on where to find that will be emailed. We do not send out a copy of the deck itself. Now I'd like to launch our poll question. When do you believe integrated carrier Wi-Fi small cell head nets will be deployed? This year, next year, sometime before 2020, or never? And while everyone's thinking about that, I want to remind you we have extensive coverage on these topics in our research. We have an analysis of small cells and Wi-Fi integration. We have a market data on small cells and carrier Wi-Fi 5-year forecast. We have a competitive assessment on small cells and carrier Wi-Fi. And we have an analysis on carrier Wi-Fi operator activity, North America, Japan, Korea, and Europe. Info on where to find these or any of our research deliverables and services can be found on our website, or you can email me directly. And we're going to review these poll answers later on in the presentation. So I'm just going to close that out. And I want to introduce Nick Marshall. He's responsible for publishing industry research on wireless radio access networks, including macro base stations, small cells, carrier Wi-Fi, and mobile backhaul. He has over 20 years experience in the wireless industry, the last 3 of which have been with ABI Research. And he's based in Texas, where I've heard there's some thunderstorms predicted, so we're hoping he's not going to lose internet access during the presentation. Nick, I'm going to hand over the controls to you.
Okay, thank you, Christine. Let me just click that. So yes, that's an interesting poll. I look forward to reviewing the results towards the end of the presentation. So hello and welcome to everybody, and thanks for taking the time to listen in today. I think it's an interesting, very interesting topic, and I'm going to outline the factors which drive each type of system to compete or complement for greater capacity or quality of experience in mobile and operator networks. So before we get into the webinar itself, I wanted just to have one slide on ABI itself. I'm not going to dwell on the details, but I just wanted to mention we're organized into 11 technology sectors outlined on that box on the right-hand side, and I represent part of our team in the mobile infrastructure sector. So for other topics, other technology topics, please take the time to go to our website and check us out. Okay, so what are we going to cover today? It's a pretty full agenda, and to start with, I'm going to outline the small cell types. It's important, I think, to clarify what we mean by small cells before discussing the details. Then I'm going to have a look at some of the drivers and limitations of integrating Wi-Fi with licensed small cells. We're going to have a look at work in progress to close some of the gaps which the industry has identified to doing that. And I'm going to finish off with a review of an example architecture, some operator examples, and their summary and outlook. So let's start by looking at the drivers behind network densification. Here we see on the left-hand side the mobile network traffic by access technology, and on the right-hand side is the same traffic by region. Both charts go out to 2019, and there is an enormous increase in network traffic, and the main growth area is coming from 4G. And as you see here, it's growing by 25 times, and according to our estimates. And on the right-hand side, we can see the growth is coming from a few regions, Asia Pacific, North America, and Western Europe, which together grow annually 69% per year. This enormous growth in traffic demand pressures networks and drives densification efforts as operators are striving to meet the demand. Densification comes in many forms, from traditional macro sectorization improvements to full-blown HETnet architectures, including licensed small cells, carrier Wi-Fi, and distributed antenna systems or DAS systems. So in the upcoming slides, I'll outline industry initiatives which are aligning to make carrier Wi-Fi and its integration with small cells a reality. As you will see, managing connectivity is the name of the game here, so that the user is always best connected. So let's look in more detail at the motivations for a mobile network operator or a multiple system operator, an MNO or an MSO, for adopting carrier Wi-Fi. MNOs, we believe now, perceive carrier Wi-Fi as a robust carrier-grade alternative access technology, and that they can have additional revenue opportunities to monetize the traffic and use it as a subscriber retention tool. MSOs, on the other hand, see carrier Wi-Fi as a way to enter mobile without the high cost of licensing spectrum. The MSO can leverage their installed hybrid fiber coax backhaul, broadband backhaul plant to do this, and in fact it becomes, they are talking now about a potential Wi-Fi first mobile system. So where the handset is Wi-Fi and it accesses the network that way. And in fact, in the US, we've seen the Cable Wi-Fi Consortium, which is Time Warner Cable, Cox, Comcast, Bright House, Optimum, now reporting up to 200,000 hotspots so far, probably more by now, and that is one of the fastest growing carrier Wi-Fi networks we've seen so far. So I thought it would be useful here to overview our definition of small cell types and briefly outline the merits of each system. So in this chart, we include Wi-Fi and distributed antenna systems alongside the traditional femto-pico metro cells and compare them to a traditional macro cell on the right-hand side. So compared to macro cells, we can see that micro cells handle hundreds of simultaneous users at a relatively high power level. These cells are usually mounted fairly high up on rooftops, and it remains still a relatively expensive solution for network densification. However, a DAS system can also handle hundreds of users at a cost, but its big advantage is its ability to offer a neutral host inside buildings, and that's its advantage so far over traditional femto, pico, and metro cells. Pico and metro cells are the traditional small cells deployed for capacity at a much lower price point than DAS or microcells. They don't yet offer neutral host operation, and that could be a problem in some enterprise or venue situations for bring your own device. They can be a low-cost way of adding capacity, but may need power, backhaul, and siting issues to be sorted out. Femtocells are deployed by the user. All these other types are deployed by the network operator, and along with Wi-Fi are one of the cheapest or least expensive ways of densifying a network. Wi-Fi, on the other hand, is low cost and has been traditionally dismissed by the mobile network operator because it operates in unlicensed spectrum, which is subject to interference. And we're going to have a look at that in some upcoming slides. And by the way, this chart is not hard and fast. Each category seems to be overlapping the other, and some systems, for example, may have small cells and Wi-Fi driving a DAS, in-building wireless system, so it's not a totally clear picture. Let's now take a look at Wi-Fi versus LTE. So I've tried to do that in this chart at a high level, and the conclusion here is that Wi-Fi is generally aligned with LTE and LTE Advanced as it evolves from 802.11n to .11ac and beyond. Wi-Fi is adopting advanced techniques such as advanced antennas, beamforming, MIMO, and channel bonding, all making it a very robust access technology. It's very similar to what 3GPP is doing for licensed carrier aggregation, is licensed way of doing channel bonding, for instance. And we're going to talk about some of the techniques in upcoming slides. So the main factors that make carrier Wi-Fi attractive is that there is abundant unlicensed spectrum that can be used by Wi-Fi without any need for regulatory approval. There is ubiquitous device support for this technology. Wi-Fi is everywhere from tablets, smartphones, handsets. In fact, some vendors are evolving small cells to include Wi-Fi as a feature, not just an option. And we have a maturing standards ecosystem, which I'll talk about in upcoming slides, and we're very close to reality for this. So let's dive a little deeper and look at carrier Wi-Fi itself. In contrast with Wi-Fi, carrier Wi-Fi is fully integrated with a mobile core, and in fact avoids the subscriber disconnecting from the mobile network to connect to Wi-Fi. We call this blind offload, and in fact that's a monetization opportunity lost for an MNO. So that's by adopting carrier Wi-Fi, the MNO gets the opportunity to monetize the traffic. The MNO or MSO's policies, authentication and billing all apply. It's seamless, secure, and always best connected. And in fact, we believe that carrier Wi-Fi finally becomes a cornerstone part of the MNO or MSO access network. There is a complex situation in standards, and I've listed here in this chart some of the activities underway. It is a maturing situation with lots of great results, but here we can see that the roles of the IEEE, the Wi-Fi Alliance, Wireless Broadband Alliance, 3GPP, Cable Labs, and the Small Cell Forum, all working towards making carrier Wi-Fi a reality. The first thing to note that carrier Wi-Fi is built on the work of the standards work on the IEEE and the certification work of the Wi-Fi Alliance Passpoint program. We'll talk about that in the next slide. The Wireless Broadband Alliance takes that and builds on it to define next generation hotspot in collaboration with 3GPP. And the Small Cell Forum takes NGH further and integrates Wi-Fi for an integrated small cell Wi-Fi architecture, or ISW. And Cable Labs does the same for the NSOs. So a lot of work going on, and I hope to outline that in the upcoming slides. So let's look at the foundation of carrier Wi-Fi. This is the Wi-Fi Alliance's Wi-Fi Certified Passpoint program. In its original release, Passpoint offers automatic network discovery and selection based on user or operator policy. It offers seamless network access based on cellular credentials or the SIM card using extensible authentication protocol. It's got robust security, and in its second release or release 2, Passpoint is further enhanced to offer online sign-up and inclusion of operator-specific subscriber policies. So we can see here that PassPoint gets us off to a pretty good start at integrating Wi-Fi with cellular. So the WBA then takes that and looks at interoperability and compliance, and in fact they build on PassPoint to facilitate connection and roaming between various operators, and they've established an interoperability compliance program, or ICP, and it involves the operators on this chart. And in fact they've completed their first network assessment and actually achieved interoperability, which is great news. These big operators here, some of the biggest in the world, have found that they can interoperate on a technical level. So as a result of that, the WBA has been able to create a set of compliance guidelines which they published in February this year, and that offers different support levels to the operators, including security, charging models, billing mechanisms, etc. So that's available on their website, and I think as a result of that, we will soon start see carrier Wi-Fi roaming. So why integrate Wi-Fi with cellular? So here I've summarized some of the benefits. The MNO can direct traffic according to policy and ensure carrier-grade security using SIM credentials. It's seamless and transparent to the subscriber. And the operator, the MNO, MSO can actually monetize this and monetize that traffic. That's actually not a subject of this webinar, but a future webinar coming up in May will have a look at that in some detail. However, it's not all paradise here. There are some drawbacks which we can look at in this slide. So here we see, we reflect some of the published work of Ericsson. Thanks to Ericsson, there are some potentially negative consequences of carrier Wi-Fi in its current form, and this points us towards future work. So when carrier Wi-Fi network selection, access point selection is driven by the device, there is the possibility of what I'm calling inefficient network selection, which lowers quality of experience and data rates. Ericsson define four different situations: reaching, they say, which is the terminal pairs with an access point too early when it's in range and risks having no data bandwidth, consuming access point resources. Unhealthy choices, where the terminal attaches even when the access point is saturated, and 3G or LTE networks may be lightly loaded. Dribbling, where the terminal attaches to the access point and there's backhaul is saturated, so data rates down. Ping pong, where frequent network selection updates are made by the terminal as you're say driving past a selection of access points downtown. But you know, I would recommend this white paper by Ericsson. I've got the link here. It's a good read. So so the question is, so how do we overcome this? Fortunately, all is not lost. We have got something called SON, or self-organizing networks. SON has been around since 3GPP release 8. TGPP continually adds sophistication to SON to aid in HetNet and small cell deployments. But the three things to bear in mind about SON are that it is making arrangements that networks can be self-configuring, self-optimizing, and self-healing. So the effect of SON is to increase spectral efficiency and optimize the network performance. SON algorithms continually assess complex RF interplay between neighboring cells and optimize data capacity and perform load balancing. When you think about installing a large small cell network, say of 100,000 small cells, you need the small cells to autonomously deploy, and that's what SON's goals are. By some estimates, SON cuts OPEX in half. So SON is still evolving, and we can get an appreciation of how this is happening by looking at the 4G America's publications. We can define SON to be centralized in the operations, administration, and maintenance or network management system back in an operations center somewhere. But that arrangement has latency and single point of failure style drawbacks. We can distribute SON in the yellow boxes here in the access point or the element management system, so that SON can react in a real-time and autonomous fashion. However, it's likely that SON will become hybrid and evolve to become popular with real-time SON decisions taken in the access point and non-time dependent decisions taken in the OEM. In complex multi-layer RANs or HETnets, non-automated systems are not practical or even viable. Still, work is still needed on multi-vendor interoperability between access points, NMS and EMS vendors, we believe. But SON is actually in use, and one of the big users of SON is AT&T, and they reported in I think 2012 that with their SON, their call drop rate was reduced by 10%. They retained 10% more 3G traffic with SON, and they had 15% fewer loaded cells. So that's an endorsement for SON, and we look forward to further evolution of SON. So properly implemented SON is going to reduce TCO and improve quality of experience. But we also need SON to extend to and encompass carrier Wi-Fi to become what the Small Cell Forum calls a unified SON. According to Small Cell Forum, there's work to do to get SON for the integrated small cell Wi-Fi access point and take care of multi-node and multi-vendor interoperability. So we believe that solving these challenges will be key to deploying ISW. Let's look at some other challenges which can help us answer the question of whether Wi-Fi can complement cellular or not. Spectrum and interference are two large topics where much work has been done. Let's look at LTE. There are over 40 frequency bands worldwide in existence for LTE, and there are a few in the 2 gigahertz range, which could potentially cause a problem with 2.4 gigahertz Wi-Fi, or vice versa. And in fact, we can see from this high-level analysis that there is the potential for trouble in the second most popular band used by MNOs, and that's band 7, highlighted by the yellow box there, band 7 uplink. LTE bands 38, 40 and 41 may also run into trouble. I may notice that China Mobile, largest MNO in the world by number of subscribers, is using bands 40 and 41, and with high-power downlinks, that could cause interference with Wi-Fi or vice versa. So to operate an ISW, you've got to have filtering for both the licensed and unlicensed RF paths in the access point. Alternatively, just switch everything to 802.11 AC at 5 gigahertz, where there is no LTE, and maybe the best alternative. But the fallback specified in AC to .11n could remain problematic. So let's make Wi-Fi carrier grade. How do people do that? First of all, RF coordination and interference mitigation is a well-studied topic, and there are several techniques available, such as COMP, or Coordinated Multipoint, and EICIC, Enhanced Intercell Interference Coordination, which we'll look at in the next few slides for licensed LTE and LTE Advanced access points. But first, borrowing from the licensed cousins, Wi-Fi access points adopt several similar techniques to overcome and mitigate interference, and I've listed a few of those here. Channel selection, where access points can select the best channel for each radio. Channel adaptation, the access point can request a channel change. Beamforming, which amplifies and directs the RF beam towards a client. Directional antennas, instead of omnidirectional antennas, it can focus RF energy on an outdoor area. Modulation encoding schemes can be changed to optimize capacity, MIMO, spatial multiplexing, transmit power control. So in fact, even although this is described in the specification, OEMs still have opportunities for competitive differentiation. I've mentioned a couple here, Ruckus Beamflex and Channelfly are two proprietary techniques that help make carrier Wi-Fi carrier grade, and Cisco Clean Air and Client Link, and there are many more. So coming to the licensed small cell area, we have COMP. I won't go into the details here, but it's a feature used to reduce interference at the cell edge. It's an interference mitigation technique, sometimes called MIMO for networks, and takes advantage of constructive interference at cell edges to increase signal to noise or SINR. It's an LTE advanced standard, but many operators are starting to implement it. For example, SK Telecom announced they're using this along with carrier aggregation in their LTE advanced network. The main challenge is to keep low latency. These cells have to communicate with each other very quickly, but it is going to prove key to effective small cell network rollouts. Another licensed technique, also very effective, another technique also very effective for licensed small cells is ICIC or EICIC, and that's Enhanced Intercell Interference Coordination. Again, originally introduced in Release 8, but continues to be enhanced in Release 10 and beyond. Release 10 is LTE Advanced. So ICIC ensures mutually exclusive frequency and power selections occur between neighboring cells, and EICIC adds a third dimension, the time domain, in Release 10, so that the cells are broadcasting when no others are. It's a major tool and is going to prove very effective for deploying head nets. It's further enhanced by something called FEICIC in Release 11 by 3GPP. Another noise reduction technique is brought to bear. But these are just two of the techniques available that are particularly interesting for head nets. And in fact, again, SKT plans EICIC this year, according to some of the comments they made. So we look forward to finding out more about that. So what are the integration options? How would we put an ISW, an integrated small cell Wi-Fi access point, together? The Small Cell Forum and the Wireless Broadband Alliance have defined several integration options. This one here, this is a RAN-based option where the combination of Wi-Fi and licensed small cell occurs in an integrated access point, which is the pink circle area on this slide. This access point also contains a facility for local breakout for non-value added traffic to further decongest the mobile core. For example, accessing a local printer or a file server. There are other ways to integrate small cell, for example, in the gateway, small cell gateway or the Wi-Fi gateway, and topic for further study. So we should see results pretty soon, according to the Small Cell Forum, and we're looking forward to that. So summarizing here what the objectives of an integrated small cell Wi-Fi access point are. It needs some form of real-time traffic steering to avoid inefficient pairing with access points. Pass point and next generation hotspot are key and need support in the network and in the user equipment or terminal. Unified SON on a per user basis is also a key requirement, and multi-vendor operability is also very important. There are some standards gaps. Small Cell Forum and Wireless Broadband Alliance have defined these and what needs to happen to make ISW a reality. So let's have a look at these. In need of standardization of definition for implementation. The reference architectures for trusted Wi-Fi networks need some work. Unified functional standardization for integrated small cell Wi-Fi access points. Policy framework, and the unified SON we mentioned. And again, we're looking forward to further publications in this area and how these gaps may be closed. So I thought it would be useful here to take a look at one example of an ISW. In fact, what I chose to mention is the China Mobile NanoCell. And they've published some information on that. You can see the NanoCell arrangement on this slide. This NanoCell offers any of the GSM, TD-SCDMA, or TD-LTE access radios in combination with Wi-Fi. It comes in a single box and shares power and backhaul with cellular. There's a NanoCell gateway for authentication. There's a NanoCell OEM used for managing the NanoCell as a local gateway for a local breakout, and they have hired an evolving ecosystem of some big names to help create this NanoCell. It's very interesting, and we'll see in later slides why they need this. NanoCell comes with its roadmap, so I think they're in the first or second or the leftmost or middle box at the moment, moving to convergence in the middle box, and then future evolution defined, which enhances the NanoCell with flexible load balancing and reduced inter-system interference, which is very much in line with the slides in this webinar. So Christine, I think this is a good spot to have a look at the poll results.
Sure. Okay, let me share those. Just to remind everybody, the poll was, when do you believe integrated carrier Wi-Fi small cell HETnets will be deployed? So I'm going to read out. Looks like 26% said this year, 35% said next year, 37% said sometime before 2020, and only 2% said never.
Okay, thank you. Yeah, well, my goodness, so I think we have the answer to our question on whether Wi-Fi complements small cells or not. You know, and it's some pretty high percentages this year and next year. So that's very interesting. It's definitely coming, and I hope that I've demonstrated that by talking about the standardization activities and operator activities in the ecosystem. So yeah, that's pretty good result.
All right, I'll hide those now.
All right. So I thought I'd move on here and wind down with a couple of operator examples of Wi-Fi and why we need to integrate Wi-Fi with small cells. On the left-hand side we have China Mobile, and on the right-hand side we have KDDI. I chose these two because they regularly report their data offload rates, or Wi-Fi or wireless LAN share of total network traffic. So they make some pretty interesting charts. China Mobile, in fact, has deployed about 4 million Wi-Fi hotspots, at least as of April last year. And they have a long-term goal to reach 6 million hotspots in the next 2 years. This operator relies heavily on its Wi-Fi footprint to offload data. And in fact, you can see the line on the chart, Wi-Fi makes up 73% of their total traffic today compared to only 28% in 2010. So that's an illustration of the enormous traffic growth and subscriber growth and how they handle it. KDDI, with similar data offload rates, draws a similar picture. They have a different approach, however. They integrate Wi-Fi with their residential fixed line broadband access points, and they reroute mobile traffic to handle nighttime traffic peaks in residential areas. So they provide to their subscribers free of charge something they call the Home Spot Cube, and they have 4 million of these deployed. KDDI also operates in public and outdoor areas and venues 230,000 access points, and they're called the AU Wi-Fi Spot, and they have said they plan to maintain an offload rate of 50% or higher as an effective way to decongest their network. So let's wrap up today's webinar with our summary and outlook. So here we summarize our outlook for small cells and carrier Wi-Fi, and we asked the question at the beginning whether Wi-Fi was complementary to licensed small cells or competitive, and I hope that you can see that we believe that it is very much complementary. We believe that the realities of increasing network traffic will mean that MNOs can now include Wi-Fi as just another access technology on a par with LTE and beyond. MSOs are also viewing Wi-Fi as a low-cost mobile access technology, and the Wi-Fi first approach to mobile wireless may well see the light of day. New revenue streams are going to attract MNOs and MSOs to implement sooner rather than later. So we're looking forward to further work from Small Cell Forum, Wireless Broadband Alliance, to close these standardization gaps. So it's just going to be a pretty interesting year, I think. So that concludes the webinar, and just to find out more, before I hand it over for Q&A, if you want to deep dive on carrier Wi-Fi, you can find out more in the AVRAN, the joint AVRAN Small Cell Forum Carrier Wi-Fi Summit in London in June. And in fact, it's much more than that. It's three conferences in one. We have small cells and small cell backhaul, and ABI is the lead analyst partner for this conference, and our Chief Research Officer, Stuart Carlaw, will be present and speaking at it. So please don't forget to check out our work in this area in our small cells and carrier Wi-Fi research service, which is on the website. So thank you for listening today, and I'll hand the session back to Christine and answer any questions you might have.
Thanks, Nick. I've already loaded some questions into the queue, so why don't you take a look at those, and we can answer some in the last minutes of the hour. Okay, all right. So let me just take a couple of minutes to peruse these. There's quite a few. Thanks for all the questions. Oh, here's one. It said, the question was, is Metrocell the same as a small cell? If not, where are small cells on slide 8? Small cells, let me find slide 8 first of all. Small cells are, they're all small cells. Yeah, here we go. The industry is calling from Wi-Fi to DAS,
systems, small cells. So they're all small cells, and what I tried to do in slide 8 is combine the licensed traditional small cell, femtocell, picocell, metrocell with Wi-Fi. So actually, they're all small cells. Here's another interesting question. What value-added services are being discussed by MNOs and MSOs? As I mentioned in the webinar, we're going to be talking about that in a future webinar, but some of the arrangements being discussed are, subscribers could pay for a high quality of experience access, a Wi-Fi link that never fails or never drops out, or high data rate. That may well be interesting to some subscribers. Wi-Fi first, I mentioned, is an alternative mobile access being considered by the MSO. The whole situation with location analytics for retail could prove interesting. Service provider could provide analytics to a shop owner to say that, subscriber 123 walked past his booth 5 times and may well be, interested in buying something. There's another one that's pretty popular as in return for sharing your broadband access with a dual SSID Wi-Fi access point in your home, you could get free roaming, and this is free roaming when you're in public areas, and this is a model adopted by FON in Spain, or Free in France. Okay, let's have a look down some of these other questions. There's a lot.